Hello friends, I, BHATIA, welcome you to my YouTube channel Maths DNA from Origin to Infinity. In this video, we are going to discuss a question of real analysis for different higher mathematics competitive exams. But before that, let me share something with you. We believe that to qualify 4 different examinations, all you need is just one single book. That is all-in-one book with 2000 plus solved questions. For this, you can register at our WhatsApp number given below. Hurry up. Moving on to the question. The question is, for the function fx equals to x minus 3 raised to 5 into x plus 1 raised to 4, x equals to minus 1 is a point of maximum value, x equals to 3 is neither a maximum nor a minimum, x equals to 7 by 9 is a point of minimum value, and option D, none of them. So this question is basically based on the derivative of the function and then finding whether the given points are maximum, minimum or none of them. Let us begin this question. First of all, as per given the question, we have function as x minus 3 raised to 5 and x plus 1 raised to 4. We have to find which of the points are maximum as well as minimum. And to do that, we will first differentiate the function, and the function is clearly differentiable. So the value of function's differentiation will be f dash x equals to x minus 3 raised to 4 into x plus 3 raised to 1 into 9x minus 7. You can easily simplify this. Now, the function is not derivable, or we can say vanishes at x equals to 3, x equals to minus 1 and x equals to 7 by 9. These 3 points are the points where the derivative of the function vanishes. So these 3 points can be either maximum, can be minimum or none of them. Let us take step by step. Firstly, for x equals to minus 1, take x less than minus 1 and be very precise. You have to just take slightly less than minus 1. So it can be minus 1.1, minus 1.2 and so on. Put the value in the derivative of the function, that is x minus 3 raised to 4, x plus 1 raised to 3 and 9x minus 7. The first term, that is x minus 3 raised to 4, for value of x less than minus 1 will be positive. The second term will be negative and the third term will again be negative. When all the 3 terms are multiplied, they give you a positive value and that will be greater than 0. See, here you just have to decide whether the sign will be negative or the positive at a given particular value. You don't need to find the complete value of the function at that point. You just need to indicate or find the sign, that whether it is positive or negative. For x equals to for x less than minus 1, slightly less we can say, it will be positive. And similarly, if we take x greater than minus 1, we get the derivative of the function's sign to be negative. So we can clearly observe that the sign of the function changes from positive to negative as x passes from minus 1. And so x equals to minus 1 will be a maximum value. So option A is correct. We will repeat the same process for x equals to 3 as well as for x equals to 7 by 9. I recommend you to pause the video over here and first try that 2 options by yourself first, as now you know what results are to be used and what things you need to be careful for. Now for x equals to 3, take x less than 3, then the value of the derivative f dash x, that is x minus 3 raised to 4, x plus 1 raised to 3 and 9x minus 7 will be plus, plus and plus, that will be positive. And similarly for x greater than 3, that is slightly more, again the derivative, that is f dash x, will be again plus, plus and plus, that will be positive. So the sign of the function does not changes at x equals to 3, the derivative does not changes its sign. So x equals to 3 is neither a maximum nor a minimum. So option B will also be correct. Now moving on to option C, x equals to 7 by 9. For x less than 7 by 9, the derivative sign will be negative, that will be less than 0. and for x greater than 7 by 9, the sign of the derivative will be positive. You can simplify this very easily. Now here the sign is changing from negative to positive. So x equals to 7 by 9 will be a point of minimum value. Thus option C is also correct. Hence our answer is option A, option B and option C. All the three options are correct. Thank you, and you can be a member of our social club and watch 550 plus videos on our YouTube channel and get a complete study material for any higher mathematics competitive exam from our WhatsApp group.